Video project by Sarah Hartline. The problem is number 3, and it states, a 30-kilogram child moving at 4 meters per second jumps onto a 50-kilogram sled that is initially at rest on a long, frictionless horizontal sheet of ice. Part A. Determine the speed of the child sled system after the child jumps onto the sled. You're going to use the momentum conservation formula, which is P naught is equal to P. This formula breaks down into the equation of m1 times v1 plus 0 is equal to m1 plus m2 times v. You're going to plug in the numbers, which are m1 is equal to 30, v1 is 4, m2 is 50, and v is the velocity, which is what you're solving for. 30 times 4 is 120, 50 plus 30 is 80, multiply it by v, you get 80v. You're going to divide by 80 on both sides, and the velocity is 1.5 meters per second. Part B. Determine the kinetic energy of the child sled system after the child jumps onto the sled. You're going to use the equation Ke, which is the kinetic energy, is equal to half times m1 plus m2 times v squared. m1 is 30, m2 is 50, and v is 1.5, which is what we solved for in part A. 50 plus 30 is 80, and 1.5 squared is 225. Half of 80 is 40, and you're going to multiply 40 times 2.25, and the kinetic energy is equal to 90 joules. After coasting at a constant speed for a short time, the child jumps off the sled in such a way that she is at rest with respect to the ice. Part C. Determine the speed of the sled after the child jumps off it. You're going to use the momentum conservation formula again, which is P naught is equal to P, and this formula will break down into the equation of m1 times v2 plus 0 is equal to m1 plus m2 times v. You're going to plug in the numbers. m1 is 50, m2 is 30, and v is the velocity, which you solve for in part A is 1.5, and you're going to solve for velocity to 50 plus 30 is 80. 80 times 1.5 is 120, and you're going to divide both sides by 50 to get V2. V2 is equal to 2.4 meters per second. Part D. Determine the kinetic energy of the child sled system when the child is at rest on the ice. You're going to use the equation Ke is equal to half times m2 times v2 squared. You're going to plug in the numbers. m2 is 50, v2 is 2.4, which is what you just solved for in part C. Half of 50 is 25. You're going to multiply it by 2.4 squared, which is 5.76. The kinetic energy is equal to 144 joules. Part E. Compare the kinetic energies that were determined in parts B and D. If the energy is greater in D than it is in B, where did the increase come from? If the energy is less in D than it is in B, where did the energy go? Part B gave us the kinetic energy of 90 joules. Part D gave us the kinetic energy of 144 joules. The energy in Part D is greater because of the energy input from the work of the child's muscles pushing on the sled. The end.